Hello students, myself Manuj from Scholars Forum. Again I welcome you all to this homemade video series of class 11th and class 12 topics. Now in the previous video of stoichiometry we discussed about sequential reaction, we discussed about percent purity, we discussed about mixture analysis. Now in this video I told you I will be discussing something very important and a very unique method for solving a numerous problem based upon this stoichiometry. That method is principle of atomic conservation. Okay, let's start P.O.A.C. If you wish to go through the previous video, please find that attachment right in the link or in the description. Or one more thing I would suggest, you go through the DBP which I'm attaching in the comment section or this description. Now, I hope you have heard conservation of energy. Are you getting this? Conservation of energy says what? Energy can neither be created nor destroyed. It can only be converted from one form to another. मतलब आप ऊर्जा मीन्स एनर्जी को आप ना तो पैदा कर सकते हो ना ही उसे खत्म कर सकते हो, बस आप क्या कर सकते हो एटमोस्ट एक फॉर्म से उसको दूसरे फॉर्म में कन्वर्ट कर सकते हो. Okay, please pardon the background noise. You know this video is being recorded at my home and try to ignore that. But what atom conservation says to us? It says that atoms can neither be created nor destroyed. Atoms can neither be created nor destroyed. But it's not like you can convert one form of atom into another. Okay, you can't do that. You can't convert sodium into oxygen. I'm talking about normal reactions. Yes, of course, in nuclear reactions, it is possible to convert one type of atom into another. But in normal reactions, you cannot convert one type of an atom into another type. Okay, so what is your principle of atomic conservation? Atoms can neither be created nor destroyed. That is, if I count a particular atom in the beginning of reaction, if I count the number of atom in the beginning of reaction, that will be equal to the number of very same atom in the end. Means कि अगर आप कोई reaction start करते हो like 100 atom of carbon लेकर के, so reaction के end में भी you will have 100 carbon atoms. Okay, if you start a reaction by let's say 1 lakh atom of sodium, so in the end of the reaction, all sodium atoms will be equal to 1 lakh. It will not be like कि 1 lakh atom will now be remaining 99,000, or it will not be like कि 1 lakh atom have converted into 1 lakh 1,000. Okay, so remember, whatever atom you have in the beginning will have the same number in the end. This is nothing but your P.O.A.C. Now before moving any forward, let me remind you, we have already discussed this, but can you do this for me? Find moles of atom which are underlined. Means I have 2 moles of what? FeC2O4. You have to find moles of carbon here. Underlined is carbon. Here 3 moles of Ne2CO3. So you have to find moles of sodium and moles of oxygen. Here you have 2 moles of K4FeCN6. So you have to find moles of carbon here. Okay, can you do this? For your help, I am doing one of these. Let's say I am doing this second one. Now, how will we solve such question? I hope you remember. If I look at 1 Na2CO3, 1 Na2CO3 means how many sodium atom you have? You have 2 sodium atom and you have 1 carbon atom and you have 3 oxygen atom. This is about 1 sodium carbonate. But how many moles of sodium carbonate you have? You have 3 moles of sodium carbonate. So 3 moles Na2CO3 means how many moles of sodium you will have? You will have, see, 3 into 2. 3 into 2. If you multiply the moles of Na2CO3 with the 2, what you will get? You will get moles of what? You will get moles of sodium. Now, how many oxygen you have in one molecule? You have 3. So if you want moles of oxygen in Na2CO3, so you should have what? 3 into 3. This 3 is what? This 3 is moles of Na2CO3. And this 3 is what? This 3 is number of O in 1 Na2CO3. Unitary method, na? 1 rupees give me 3 toffees. So 3 rupees will give me 9 toffees. So how many moles of oxygen atom you have here? You have 9 moles of oxygen atom. Now leave your answer in the comment section about moles of carbon here in Fe2C2O4 and moles of carbon here. How many carbon you can see in this K4FeCN6? See, it is whole 6, na? So in one molecule you can see 6 carbon. Okay, that's enough. So you saw, give me the answer in the comment section. Okay, let's move forward and please try to forget this background noise. Now let me illustrate this method by giving you a simple example. See, example is Find moles of CO formed by treating 16 gram of O2 with excess of carbon. Means what is happening here? We are having carbon. We are treating carbon with oxygen, and what we are getting? We are getting CO. Now I hope you can see I wrote this reaction in a very peculiar method. Means I don't write reaction like this. Now how do we write reaction? We write reaction like this. C plus O2 gives us CO. This type of reaction we write. Then we balance it. How we will balance? Let's see 2C here, 2CO here. That's how we balance the reaction. Why I'm giving you P.O.A.C as a method? If I don't give you P.O.A.C, it's not like something wrong will happen to you. You can solve all the question of stoichiometry by normal mole concept. If 1 mole react with 2, so 2 will react with 4, like that. 1 mole will give you 3 moles, so 2 will give you 6 moles. You can solve all the questions like that. But why I'm giving you this method? Because this method will allow you to avoid reaction for a very long extent. Means you don't need to form reaction here if you have understood the concept. Okay, what you have to take care here? You have to take care about the atoms, where atoms are going. Okay, now let's see by this example. See what is happening here. Whatever oxygen you have, that oxygen is converting into what? CO. That oxygen atom converting into what? CO. Now you have taken carbon in what? Excess. So tell me, all the carbon is converting into CO? No, it's not like that. Not all the carbon are converting into CO. Some of the carbon will be left here. Why? Because we have used carbon in excess. Now, can I say all the oxygen atom are converting into CO? Yes, that you can see. All the oxygen atom are converting into what? CO. So here or here, if you don't balance this reaction, nothing wrong will happen. Nothing wrong will happen. Let me show you how. Now, can I write this? The moles of oxygen atom in the beginning equals to in the end. Is this clear? You can't say the same thing about carbon. Why? Because it's not like, let's say, here you have taken 1 lakh atom of carbon. Yeah, 1 lakh mole of carbon. Doesn't matter. 1 lakh mole of carbon. It's not like all the moles are converting into CO. Why? Because who is the limiting reagent? O2. Okay. So we can say about oxygen, all the oxygen atoms, I'm saying atom. Remember, I'm not saying molecule. I'm saying atom are converting into CO. So that's why I wrote in oxygen atom in the beginning equals to oxygen atom in the end for my reaction. For my reaction, I am concerned about reaction only. Remember, I am concerned about reaction. It's not like here carbon atom will change. No, carbon atom will remain same. But in my reaction, whatever oxygen you will see left side, the very same oxygen atom will go to the right side. Clear? Now let me count the moles of O2. Moles of O2. How many moles of O2 I have taken? I have taken 16 upon 32. That is half mole. I have taken half mole of what? O2. Now, so I am writing this. The moles of O in O2. That's what I have in the beginning. O2 will be equals to moles of O in CO. Moles of O in CO. Clear this thing? Good. Now, let's assume the moles of CO formed are X. What is X? X is moles of CO. Now, see, I am going to write here moles of O. How many moles of O2 I have? I have half moles of O2. This is what written. This is written moles of O2. Okay. Now, am I conserving moles of O or moles of O2? Remember, I am not conserving moles of O2. I am conserving mole of O. Means I am conserving atoms. I am not conserving this molecule. So moles of O here. If I want to find moles of O, so each O2 contains how many O? Each O2 contains 2O. So if I multiply this thing by 2, as we did in the previous example, so it will give me what? It will give me moles of O. Are you getting this? Good. Each O2 contains 2O. Now, how many moles of CO I have? I have X moles of CO. So equals to X. Now each CO, am I consuming moles of CO? No, I am consuming moles of O. So in each CO, how many oxygen you can see? You can see one oxygen. So X into 1. If I just write X, so it will be moles of C. If I moles of CO. If I multiply this by 1, so it will become moles of O. Now from here, I am getting X is equals to 1. Is this clear to us? So you got 1 mole of CO. Clear? Now this question you can easily solve by forming the reaction as well. If 2C plus O2 gives 2CO. Here you have got half mole. 1 mole O2 forms 2CO, so half will form 1CO. That you can easily solve by mole concept. So I will suggest, if you are able to form reaction easily, don't go for P.O.A.C. Form reaction easily, balance it, solve it by normal mole concept method. If you find that no reaction formation is difficult, then I will suggest don't use mole concept, that because if you can't form reaction, your answer will be wrong. So focus on this method as well. Okay. Now let me give you a very dangerous question. If you will look at this question, you will faint. You will surely get fainted. You will simply say, sir, this is impossible, we can't do it. Okay, let's see the question. What they are saying, during a reaction of sulfur, we had a sulfur's reaction. It was converted into SO2 by reaction with O2. Means we treated sulfur with O2, so we got SO2. Now further it was oxidized by Cl2 water to form H2SO4. Means somehow we formed H2SO4 by reacting this SO2 with Cl2 water, which upon reaction with NaOH followed by heating gave Ne2H2O3. Okay, as the final product. They are saying if in the beginning we had 32 gram of sulfur, then find the weight of Ne2H2O3 formed. Question is clear? If you want to give it a try, you can. Okay, and let me tell you, you will take a lot of time in this question. आधे लोग हाथ खड़े करेंगे because sir, it's impossible for us. But let's see what actually is happening in this reaction. So let's see. You had sulfur. It was treated with what? O2. It got converted into SO2. Now, again what you did, you treated this SO2 with chlorine and water. So they are saying you are getting H2SO4, isn't it? You are getting H2SO4. They are saying this. Now upon reaction with NaOH, let me tell you, I hope you know, if you treat it with NaOH, you will get Na2SO4. But they are saying we are not stopping at Na2SO4, we are further heating it. So upon heating, somehow you are getting Na2H2O3. I don't know how you are getting this, but you are getting this. So they are saying, tell me the weight of Na2H2O3 formed. Okay. Now, what if I tell you whatever sulfur atoms are present here, atoms, I am saying atoms, those atoms are coming from where? They are coming from H2SO4, isn't it? Sulfur, from where sulfur is coming, this Na2H2O3? It is coming from H2SO4. Now, whatever sulfur is present here in H2SO4, it is coming from where? It is coming from SO2. See, SO2 is having sulfur now, so SO2 is converting into H2SO4 now. So whatever sulfur you have got here, that the very same sulfur you got in SO2. And now whatever is sulfur you got in SO2, from where it is coming? It is coming from sulfur. Is this thing clear to us? So can I write one thing? I am going to write this. The moles of S in S, moles of sulfur in sulfur equals to moles of sulfur in SO2 equals to moles of sulfur in H2SO4 equals to moles of sulfur in Na2H2O3. Can I say this thing or not? Yes. Now they have given you more. They have given you the weight of sulfur. How much weight they have given? They have given 32 gram of sulfur. So can you tell me how many moles of sulfur you got? Let's just calculate it here. So moles of sulfur, how much? Moles of sulfur you got 32 divided by 32, that is 1. Okay. Now they are saying find the weight of Na2H2O3. So let me assume some weight. Let's say the weight of Na2S2O3 is equal to how much? It is, let's say, W. Okay. Now, can you tell me the molar mass of Na2S2O3? Let's check. What is molar mass of Na2S2O3? It will be 2 sodium, that is 46, 2 sulfur, 64, 3 oxygen, 48. Now, how much it is coming? Can you calculate it for me? Okay, so it is coming as 8, 4, 12, 12, 6, 18, carry 1, 4, 5, 5, 6, 11, 11 and 4, 15. It is coming as 158, isn't it? Okay. Now, molar mass of Na2S2O3 is 158. Can we calculate the moles of Na2S2O3 now? Yes. Now, moles of Na2S3 will be how much? Moles of Na2S2O3 will be equal to W upon 158. Please pardon the background noise. Okay. Now, before writing any further, let me clarify one thing from you only. Tell me, can I say this? If whatever moles of oxygen you have here, the exact same oxygen number you have in H2SO4. Think about this. Whatever moles of oxygen atom you got here, the very same oxygen atom you have here also. Can I say this? No. आप ऐसा नहीं बोल सकते कि जितने ऑक्सीजन के एटम यहां पे होंगे उतने ऑक्सीजन के एटम यहां भी होंगे, मींस H2SO4 में होंगे. क्यों नहीं बोल सकते आप ऐसा? Because H2SO4 is not the only source of oxygen here. H2SO4 is not the only source of oxygen here. Maybe oxygen is coming from NaOH also. Maybe oxygen is coming from NaOH also. You can't say. Okay, so you can't say ki whatever NaOH, whatever oxygen atom before the reaction, you can't say like that. Okay, now can you say one thing here? Whatever oxygen atom you have here in H2SO4, those are exact in SO2. No, you can't say. Why? Because SO2 is reacting with water as well. Na? So water may give some oxygen. So that's why this SO2 with water may be, one thing you can say, if whatever oxygen atom you got here, those oxygen atom will be equals to oxygen atom here in SO2 plus oxygen atom here in H2O. That you can say, but you can't say like that. Why I am saying this? Because for forming of this equation, you need the knowledge about where your atom is going. You must have this knowledge. Okay. Now, I am cancelling this. There is no need to write this. Now, how many moles of sulfur you got here? You got 1 mole of sulfur. Now, this will be equal to how much? See, how many moles of Na2S2O3 you got? You got W upon 158. What is this? This is moles of Na2S2O3. But are you equating moles of Na2S2O3? No, you are equating moles of sulfur. So tell me, by how much number I should multiply here so I will get moles of sulfur? Each Na2S2O3 got how many sulfur? 2. So if I multiply this with 2, so this will be nothing but it will be moles of sulfur. Are you getting this? Now from here, W is coming how much? It is coming as 158 divided by 2 means 79 gram. That's it. How long this question was? See, question was having 4 lines. Solution, it's in front of you. I hope this thing is clear to you. Okay, let's see another question. I hope you have seen such type of question. Yes, you have. You have seen the very same type of question in the previous video. Now, here what is happening? Carbon is reacting with H2 to give you C2H2. Then C2H2 is again treated with H2 to give you C2H4. C2H4 is again treated with O2 to give you CO2 and H2O. One method you have, you can balance the reaction and you can easily solve this question. I will suggest that if you are not familiar or comfortable with P.O.A.C, then you can form the reaction easily. So you go by mole concept. But let me show you, if you don't know about mole concept or you feel like I have command over this P.O.A.C, so let's see how easily you can solve this question. Now what if I tell you, now firstly let's see the question. They are saying find the moles of CO2 formed if the reaction was started with 6 gram of carbon. Means you started this reaction with 6 gram of carbon. Now I am asking you moles of CO2 formed. Now let's see. Can I say whatever carbon atom you have here, the very same carbon atom will be in C2H2. Can I say this? Yes. Now whatever carbon atom you have in C2H2, the very same carbon atom you have in C2H4. Can I say this thing? Yes. Whatever carbon atom I have in C2H4, the very same carbon atom are present in CO2. Can you see this thing? कैन यू ऑब्जर्व दिस? जो भी कार्बन एटम यहाँ है वो यहाँ पे होगा, जो कार्बन एटम यहाँ है वो पूरा का पूरा यहाँ गया है, जो कार्बन का एटम यहाँ पे वो पूरा का पूरा यहाँ गया है. क्या मैं ऐसा बोल सकता हूँ? यस, आई कैन से दिस. नाउ वन मोर थिंग आई एम आस्किंग कि कैन आई से दिस? Moles of H2 present here means H जितना भी H यहाँ है, whatever H is present here, the very same H is present here. Can I say this? Yes, I can say. Now, can I say this? Whatever H is present here, the very same H is present here. No. Why? Because you got one more source of H, isn't it? You can say this. Whatever H is here, that is H here plus H here. Okay. Now, tell me one thing. Can I say whatever O you have here, that O you also have here? No, you can't say, because here oxygen is going into two parts. Oxygen is going in CO2 as well as in H2O. You can say one, whatever oxygen atom you have here, those are present here plus here. Okay, so I am going to do one thing just. Moles of carbon in C equals to moles of carbon in CO2. That's it. I'm not writing these intermediate steps. Now, how will I do this? Let's see. How many gram of carbon I have? I have 6 upon 12 gram. So this is nothing but, I have 6 gram. So it is nothing but moles of carbon. Now, let's say moles of CO2 are X moles. So X moles, what is X? X is moles of CO2. But am I equating moles of CO2? No, I am equating moles of C. Now, each CO2 contains how many C? Each CO2 contains 1 C. See, just 1 C is present here. So if I multiply this thing by 1, so what I will get here? It will be moles of C. If you multiply this X by 2, you will get moles of O. But we are not equating moles of O, we are equating moles of C. So I hope you are getting this, 1 by 2. Now from here, X is equals to half. So you got half moles of CO2. I hope this question is clear to us. Good. Let's move forward. Now next question is, Na2SO4.XH2O, upon heating, it loses 55.9% of its weight and becomes anhydrous. So they are saying find the value of X. Now, there are two methods for solving this question. I will explain both. Now, in this question, they are saying we have Na2SO4.XH2O, and upon heating, you will get what? Na2SO4 plus XH2O. You're getting this thing, and it is, this is what? Anhydrous, means no water in it. Okay, anhydrous means clear. Good. Now you can solve this question by one thing. Like you can do one thing. Can you tell me the molecular mass of molecular mass of this Na2SO4.XH2? So its molecular mass will be, there are 2 sodium. 2 sodium means 2 into 43 or 2 into 23, plus you have 1 sulfur. Sulfur 1, 32, 6 of 4 oxygen, 64. So 32 and 64 will be 96. Means Na2SO4 is 96 plus 18x. Why 18x? Because water molecule has molecular mass 18. There are x water molecules, so 18x. So it is coming as, I believe, 142. 46 plus 96, that is 142 plus 18x. Okay. Can I say one thing? If you understand, whatever water molecule I have here, the same water molecule will be here also. Can I say this or not? Yes, I can say this. Now, you should assume some weight here about Na2SO4. Let's do one thing. Let's say the weight of Na2SO4.XH2O is equals to 100 gram. Let's assume a weight. That will make calculation easy. Okay. If you don't want to assume 100, you can assume whatever weight you want. You can assume X gram. X you can't assume because X is already given here. You can assume W gram. You can assume capital Z gram, whatever. Okay. Now I have assumed 100 gram of it. Now can you tell me how much weight this is losing? How much weight this Na2SO4.XH2 is losing? It is losing 55.9%. 55.9%. Now can you tell me this 55.9% will be the weight of what? It will be the weight of Na2SO4. No, we are not losing weight of Na2SO4. We are losing weight in form of water. Why? Because this water must be vaporizing. So whatever weight loss is happening, so weight loss is equals to due to water. Weight loss is due to water. And can you tell me, out of 100 gram, how much weight of water will be there? It will be 55.9%. That means 55.9 gram of water. Isn't it? Now, I am writing here moles of H2O in the beginning equals to moles of H2O in the end. Are you getting this thing? Good. Moles of H2O in the beginning equals to moles of H2O in the end. Now, how many moles of H2O I have in the beginning? Let's see. Do I have H2O in the beginning? No, I have Na2SO4.XH2O in the beginning. Now, so if I want to write this, if I write this 100 upon 142 plus 18x, so you can लिखा है. What is this? This is moles of Na2SO4 dot XH2O. Now, each Na2SO4 dot XH2O contains how many H2O? It contains XH2O. So if I multiply this by X, so what will I get? This is moles of water. This is moles of water. Because each molecule of Na2SO4 contains how many molecules of H2O? X. So multiply by X equals to how many gram of water you are getting there? You are getting 55.9 gram of water now. 55.9 gram of water out of 100 gram of it. So 55.9 gram water में कितने moles हो गए पानी के? How many moles will be there in 55.9 gram of water? It will be 55.9 divided by 18. This thing is clear to us. Now you have got an equation for you. You have got an equation for you. Can you solve this equation? Yes, I hope you can. Now let me tell you, if you will solve this equation, this is a very famous question, you will get x approximately equals to 10. You try to solve this, you will get x equals to 10, or if you wish, I can solve it here. Now, solving is not that difficult. See, this multiplying here, you will easily get this. Okay, approximately 10 will be your answer. So this is your one method for solving this question. Okay, let me show you second method. Now let's see this second method. Now, you are losing 55.9% of weight. I hope you know that whatever weight you are losing, that is because of water only. That is because of water. So means I am saying weight loss is equals to weight of water only. Okay. Now what is molecular mass of 142 of this molecule? This entire molecule has mass 142 plus 18x. Now can you tell me weight? How much weight of water is present here? Weight of water is what? It will be 18x. Now, out of this, what is the weight of water? Just 18x. Now, can you tell me what is this? 18x divided by 142 in plus 18x into 100. What I have written this? What I have written this? This is what? This is weight of water. This is what? This is weight of entire Na2SO4 dot XH2O. And if I multiply this by 100, what I am getting here? I am writing simply percentage of H2O. Are you getting this? Now please pardon the background noise. Now what is the percentage of H2O given in this question? 55.9. So this value is nothing but 55.9. So here I am writing 18x divided by 142 plus 18x into 100 will be 55.9. If you solve it here again, you will get approximately equals to 10. Okay, please do the calculation for sure on your own. Okay, so this is your another method. Okay, now we have discussed about P.O.A.C in this video. P.O.A.C is a tool which you can utilize when you are finding reaction formation is difficult, and also you can apply this method when you see that atom distribution is quite clear to you. So you can apply this method in any question related to stoichiometry. It will give you very good answer. But don't apply this method when you are not sure about movement of atom, कि atom हमारा जा कहाँ रहा है, या एक atom एक molecule में किसी atom की एक से ज़्यादा source है. Please don't apply if you are not clear about the source of atom. Okay. One more time, you don't apply this method wherever question is given about percent yield. If you see they are asking about percent yield, don't apply this method. Why? Because in percent yield, if I am talking about percent yield, that means I am not saying that 100% reaction is not happening. So you can't say that whatever atom are in the reactant, those very same atom will go in product. You can't say that. So don't apply this method in percent yield question also. Okay. So solve the DPP which I have attached, and the rest we will discuss in the next video with some other question. Till then, keep studying. Have a good day. Bye bye.